Hello everyone. For today's lesson, we're going to talk about impulse and momentum, just a part of the chapter about impulse, momentum, and collision. Ano nga ba ang momentum at ano ba ang impulse? So, one application of impulse and momentum ay kung paano ito ina-apply sa airbag. Okay, so paano nga ba nagfa-function ang airbag? Ano ang ginagawa nito sa force at bakit nababawasan ang injury during collision? And we're going to discover about that in this lesson. Problems on impulse and momentum. So let's go and let's start the discussion. So for the first part, we're going to talk about momentum, and the second part will be about impulse. So what is momentum? Okay, so to visualize, ano nga ba ang momentum? Let's say for example, ikaw ay nanonood ng movie and bigla kang inutusan sa point na kung saan nasa climax ka ng pinapanood ng movie. Agad-agad ka bang tatayo para sundin kung anong iniutos sa'yo? Well, that describes what is momentum, and it's the same definition in the context of physics. You were at the point when you were unstoppable. And when we say momentum, ibig sabihin nun, it is a physical quantity that describes how unstoppable an object is. Tingnan natin yung isa pang example. I know very familiar kayo sa dalawang ito, yung BBM Sara, because this was year 2022 when they were thought to have the political momentum. At pag sinabi natin momentum in the context of the election last 2022 is that they are already unstoppable. Therefore, by definition, when we talk about momentum, it describes how unstoppable an object is. At ano nga ba yung mga factors that affects how, what are the factors that affect how unstoppable an object is? Okay, number one, of course, ay yung bigat ng object, or in physics, that is called the mass of an object. Pag mas mabigat ang isang object, mas mahirap siyang patigilin. Another, bukod sa bigat or bukod sa mass ng object, is also its velocity. By definition, momentum is a measurement of how mass in motion. It tells us how much mass is in how much motion. And it is denoted by the symbol P with an arrow on top of it, because momentum is a vector quantity. Now, the SI unit for momentum is kilogram meter per second. Question: does an object at rest have momentum, and why? In our definition of momentum, ang sabi natin, gaano kahirap patigilan ang isang bagay na gumagalaw. Ngayon, kapag ang object ay at rest, hindi siya gumagalaw, therefore, the momentum is zero. So, mathematically, momentum is denoted by the symbol P with an arrow on top, which is equal to the product of the mass and the velocity. Now let's try to solve problems on momentum. Let's have the first problem. Number one, a cheetah, known for its incredible speed, can reach a top speed of 30 meters per second while chasing its prey. Assume the cheetah has a mass of 50 kilograms. Letter A, calculate the momentum of the cheetah at its top speed. And letter B, if the cheetah accelerates from rest to its top speed in 4 seconds, what is the average force exerted by the cheetah during this acceleration? You may pause the video and try to solve on your own. Now, let's start to solve the problem. So first thing that we need to do is to list all the given values. What is the mass of the object? So mass is equal to 50 kilogram. Okay, so we have 50.0 kilogram. Next, the top speed, or we can say that that is the final speed of the object, and that is 30.0 meter per second. Now, what is being asked in the problem for letter A? What is the momentum of the object? So based on our definition of momentum earlier, momentum is the product of the mass and the velocity. So solving that, we have P is equal to the mass, which is 50.0 times the final speed, that's the velocity, maximum speed, which is 30.0. And then we just multiply that. We have 5 times 3 is equal to 15, and we have 2 zeros. So it's 1,500 kilogram meter per second. So that is the momentum of the object at its top speed. How about for the second question? So for the second question, it is asking for the average force exerted to accelerate from rest to its top speed. So initially, we will assume that the object is at rest. So initial speed is equal to 0 meter per second. Now, if we're going to go back to Newton's second law, Newton's second law states that force is equal to the mass times the acceleration of the object. We have the mass of the object, but we do not know yet what is the acceleration. Okay, so with this, we need to get the acceleration, and acceleration is equal to the change in the velocity over the change in time. Therefore, deriving the equation of Newton's second law, force is equal to the mass times the change in the velocity, which is the difference between the final and the initial velocity, divided by the time. And in our in our problem, the time to reach that speed is equal to 4.00 seconds. So we have force is equal to the mass, which is 50.0 times the final speed, which is 30.0, minus the initial speed, which is 0, which is, we can just leave it blank, divided by the time, which is 4 seconds. Therefore, we have, so we have 1,500. So if we're going to calculate that using our calculator, that's 50 times 30 is 1,500 divided by 4, which is equal to 375. Therefore, the average force exerted to reach that acceleration is 375 newtons. As simple as that. Now for next problem, let us consider a chemical reaction between nitrogen and hydrogen. So let's have the problem. In a closed container, nitrogen gas and hydrogen gas react to form ammonia. In the following balanced equation, N2 plus 3H2 yields 2NH3. A molecule of nitrogen, N2, has a mass of 2.802 times 10 raised to negative 25 kilogram and travels at 500 meters per second in the positive x direction. Hydrogen has a mass of 3.34 times 10 raised to 27 kilogram, moving at 800 meters per second in the negative x direction. Determine the total momentum of the system before the reaction occurs. So let's first have an illustration of the problem. And according to our problem, there is only one molecule of nitrogen and three molecules of hydrogen. So the one molecule of hydrogen is moving in the positive x direction. It is moving toward the hydrogen molecules. And the hydrogen molecule, we have 3 hydrogen molecule. All of them are moving in the negative x direction. So before we proceed with that, before we can calculate the total momentum of the system, that is actually the net momentum of the system. And since momentum is a vector quantity, we're going to apply your vector addition. So the total momentum of the system is equal to the momentum of the nitrogen plus the momentum of the hydrogen molecule. Now, we have 3 molecules of hydrogen. Take note of that. And 1 molecule of hydrogen is 3.34 times 10 raised to negative 27 kilogram. Okay, so let's list our given values. Okay, so we have the mass of the hydrogen molecule, nitrogen. So let's put first here nitrogen molecule. So the mass of the nitrogen molecule is 2.802 times 10 raised to negative 25 kilogram. And the speed or the velocity of the nitrogen molecule, since it's moving in the positive x direction, it's positive 500 meter per second. On the other hand, the mass of the hydrogen molecule is, we have 3 molecules as stated in the balance equation. We have 3 molecules. So we have 3 times 3.34 times 10 raised to negative 27 kilogram. And that is equal to, if we're going to use your calculator, that is 3.34 times 10 raised to negative 27 times 3 is equal to 2.8002. So we have 2.8002. I'm sorry. It's let's pause that. 3 times 3.34 times 10 raised to negative 27. It's 1.002. Sorry. So let's list that one. Let's erase it. It's 1.002 times 10 raised to negative 26 kilograms. So that's the total mass of the hydrogen molecule. And the speed of the hydrogen molecule, V sub h, is equal to negative 800 meter per second. Now, since it's just in the x, so we only have the x component of the velocities, therefore, we just have to add or the net momentum is just in the x component or in the horizontal components. So first thing we need to do is to calculate the momentum of the nitrogen molecule. So calculating the momentum of the nitrogen, we have the mass of the nitrogen molecule times the speed of the nitrogen molecule. So we have mass, which is 2.802 times 10 raised to negative 25 times the speed, which is 500 meter per second. And then we have, now we don't need to actually put the unit in that case. So let's have 2.802 times 10 raised to negative 25 times 500. We have 1.401. So that's 1.401 times 10 raised to negative 22 kilogram meter per second. Now, for the momentum of the hydrogen molecule, we just have to multiply the total mass of the hydrogen molecule times the velocity of the hydrogen molecule. So we have 1.002 times 10 raised to negative 26 times the speed, which is negative 800. And multiplying that, we have 1.002 times 10 raised to minus 26 equals times 800. That's equal to negative 8.016. Okay, so it's negative 8.016 times 10. Let's just wait for it. 10 raised to negative 24 kilogram meter per second. Okay, that's meter per second. And then let's just assume that there's meter per second in there. Next, what we need to do is to get the total momentum. The total momentum is equal to the momentum of the nitrogen molecule plus the momentum of the hydrogen molecule. And solving that, we have 1.401 times 10 raised to negative 22 plus negative 8.016 times 10 raised to negative 24. Okay, so we just have to use our calculator for that, and that is 1.401 times 10 raised to negative 22 minus 8.016 times 10 raised to negative 24. And the answer is 1.321. So the final answer is 1.321 times 10 raised to negative 22 kilogram meter per second. So that is our final answer. Therefore, the net momentum or the total momentum of the system before a reaction is 1.321 times 10 raised to negative 22 kilogram meter per second. Okay, let's have another problem. After hitting the cue ball against an object ball, the cue ball with a mass of 0.170 kg is moving at 1.50 meters per second at 30-degree angle with the horizontal. The object ball, 0.160 kg, travels at a speed of 3.30 meters per second at an angle of 120 degrees with the horizontal. What is the total momentum of the system? If we're going to draw the But before that, you may pause the video and try to solve the problem on your own. Now, illustrating the problem, we have this illustration. So as you can see, okay, this is our object ball, cue ball, sorry. This is our object ball. So as you can see, they are in the XY plane. So for that, we need to find first the X component, which is this one. We're going to get this X component. We just subtract the X component of both. Okay. So most probably it would be here. And then the Y component is the sum of your vertical components. So we just have to have your VAX, your VBX, and also here the y component of the velocity of A, VAY, and the y component of your V sub B, so VBY. For that, we're going to use we're going to get the summation of the momentum in both horizontal and the vertical components. So let's try to solve the problem. Okay, so let's start with the given values. We have the mass of A, which is your cue ball, which is 0.170 kilogram. We also have the mass of B, which is 0.160 kilogram. We also have V, or the velocity of A, which is equal to 1.50 meter per second, an angle of 30 degrees. B sub B is equal to 3.30 meter per second. That's 3.30 meter per second at an angle of 120 degrees. So for this, we need to first find the x and y components. Okay, so we need to get the momentum in the x component, which is the mass of A, and the velocity, the x component of the velocity of A, plus the mass of B and the x component of its velocity. Sorry. The x component of the velocity of. So, since we have that, how do we get again the x and y components? Since this is just your 180-degree angle, so we can just use, for the x component, you can use your cosine of the angle. So for letter A, for the first, or for the object ball, to get the x component of the velocity of the object ball, that's 1.50 cosine of 30 degrees. That's for the x component. On the other hand, for V sub B, it's 3.30 cosine of 120 degrees. So we need to get first the x component. So VAX is equal to 1.50 cosine of 30 degrees. And 1.50 cosine 30 degrees is equal to 1.299. So we'll get your 1.299. So that's the x component of V sub A. For the y component, for the x component of V sub B, that is equal to 3.30 cosine of 120 degrees. And 3.30 cosine of 120 is equal to negative, it's negative 2.077. So negative 2.077. So we'll use this as the x component, or the horizontal components of the velocity of A and B, or the cue ball and the object ball. So using that, we can use your formula. P in the x component is equal to ma B sub ax plus m sub b sub bx. So using that, we have the mass of A, which is 0.170 times the x component of the velocity of A, that's 1.299, plus the mass of B, which is 0.160 times the x component of the velocity of B, which is negative 2.077. And calculating that, we have 0.170 times 1.299 plus 0.160 times negative 2.077, that is equal to negative 0. So getting the sum of that is negative 0.111. So V, the momentum in the x component, is equal to negative 0.111, or that is actually 112, sorry. Okay, so let's have that. Now, after getting the horizontal component of the momentum, we get the vertical component of the momentum. P sub y is equal to m sub a times your v sub ay plus m sub b times v of b sub y. And b sub ay is just the same. Let's just change this cosine into sine. So let's do it directly. So we have m sub a, which is 0.170 times the velocity, which is 1.50 sine 30 degrees, plus 0.160 times 3.30 sine of 120 degrees. Okay, so solving that, we have, okay, so if we're going to solve that, calculate that, we have 0.170 times 1.50 sine 30 plus 0.160 times 3.30 sine of 120, we have 0.585. So it's 0.585. Okay, so we now have your P sub x, or the horizontal and vertical component of your momentum, total momentum. And it's on. If we're going to draw your resultant vector, it lies in the second quadrant. Okay, so it lies in the second quadrant. So what we're going to do is we're going to get the magnitude of the net total momentum. So the magnitude of the total momentum is equal to the square root, that is applying the Pythagorean theorem. So that is your P sub x squared plus your P sub y squared. And the magnitude of the total momentum is equal to the square root of negative 0.112 plus squared plus 0.585 squared. And solving that, we get, what is that? Square root of 0.112 squared plus 0.585 squared, which is 0.596. So it's 0.596 kilogram meter per second. So that is the um, magnitude of the momentum. The uh, how about the direction? Since this is a vector quantity, we need to find the direction. And to find the direction, theta, we're going to use your theta is equal to the inverse of your tangent times your p sub y over the p sub x. And that is p sub y, which is 0. Inverse tan, sorry. We'll just erase that. Okay. Okay, so inverse tangent p sub y is 0.585 divided by negative 0.112. Therefore, your tangent, your theta, so we just have put shift tangent and then the ratio, it's 0.585 divided by negative 0.112. And the answer to that is 79.16, or it's actually 79.2. So three significant figures, negative 79. It's negative 79.2 degrees. And it's this angle right in here. Okay, so if we're going to illustrate that, it's on quadrant 2 and it starts in the negative x-axis. This angle here is 79.2 degrees. Now, since we're going to use this angle to represent our answer, okay, what we're going to do is to subtract that from your 180-degree angle. So it's 180 minus 79. 180 degrees minus 79.2 degrees is equal to, okay, sorry, 180 minus 79.2 is equal to 100.8 degrees. So it's just 100, it's about 100.8 degrees. So if we're going to write our final answer, it would be, so the final answer, the total momentum is equal to 0.596. It's 0.596 kilogram meter per second and 100.8 degrees. And that is the total momentum of the system. Now, for another question, let us go back to my question earlier regarding how does an airbag minimize severe injuries during car crash. This is actually explained by the concept of impulse. And what is impulse? So, by definition, impulse is the change in momentum. And when you say change in momentum, it's your delta P. Okay, it is denoted by the symbol J with an arrow on top, which denotes that impulse is a vector quantity. The SI unit of impulse is Newton seconds. Now, what are the two factors on which momentum and impulse depend? So let's try to go back to your Newton's second law. So Newton's second law states that force is equal to the mass times acceleration. We actually had a problem like this uh, in our previous example. So we have force is equal to the mass times the acceleration. That is Newton's second law. Ngayon, kung babalikan natin ang equation ng acceleration, acceleration is the change in the velocity over time. So if we're going to substitute A here, so we have F, or the force is equal to the mass times the change in the velocity over the change in time. Now, look at your F is equal to force is equal to mass times the final velocity minus the initial velocity over time. Now, therefore, force is equal to, i-distribute lang natin ang ating mass. So, we distribute that. We have mass times the final velocity minus mass times the initial velocity divided by the change in time. Now, if we're going to look at this, mass times the final velocity is the final momentum of the object, and mass times the initial velocity is also the initial momentum of the object. So, force is equal to the final momentum minus the initial momentum over the change in time. Now, final momentum minus the initial momentum is also the change in the momentum of the object, which is also the same as impulse. As we defined impulse earlier, sabi natin, impulse is the change in momentum. So, force is equal to the change in momentum over the change in time. Now, since this is the change in momentum, we can say that this is also the impulse of the object, because it's mathematically defined as the change in momentum. So, the change in momentum is equal to the force times the change in time. Sabi natin kanina, impulse is the change in momentum. Therefore, we can represent delta P as your J, which is equal to force times the change in time. Therefore, we can also equate this as F times delta T is equal to the mass times delta V. Or the impulse is also equal to the change in the momentum, which is our definition of impulse. Okay. Now, these are the two quantities in which impulse and momentum are dependent, are dependent. It's force and time intervals. So, during collision, what happens is that the momentum changes. Nagbabago yung momentum kasi nga, yung object comes from a very fast speed and then it goes to a sudden stop. Therefore, there is a very great change in momentum. Ibig sabihin, taas ng change in momentum. At kapag mataas yung change in momentum, ano ang kailangan mangyari? That momentum should be transferred in the form of a force. Okay, that momentum, the change in momentum should be transferred. Now, if we keep, it's because during collisions, hindi naman natin pwedeng baguhin yung change in momentum kasi nga, hindi natin pwedeng baguhin yung speed. Therefore, the change in momentum is just constant. Now, if the time interval is very small, what happens is the force must be very large, or the force should be very large. It's because we're keeping the change in momentum constant. And if we made the time interval shorter, then force will be greater. But if we're going to increase the time interval, force will be smaller. That is the very concept paano nagkakaroon ng, or paano lumiliit yung force na na-experience during collision. As you can see, for example, this is your, if you look at my hand, if this is the head of the person doon sa steering wheel, and then ito yung steering wheel. Kapag walang airbag, mabilis niyang inaabot yung steering wheel. Therefore, the time of contact between the head of the person and the steering wheel becomes shorter. And what the airbag does is, di ba, nag-inflate yung airbag, ang unang nako-contact ng head ng occupant ay yung airbag, and then the airbag will slowly deflate. So instead of reaching the steering wheel at a very short period of time, in a very short period of time, what happens is pinapabagal na yung time of contact between the person's head and the steering wheel, which reduces the force between them. That is the very concept how airbags function. Now, let's try to solve problems on impulse. Now, according to a study, Manny Pacquiao's punch delivers an average force of 806 pounds, approximately 3,585 newton, on a heavy bag over a contact time of 0.120 seconds. If during this punch, his fist slowed down from 30 meter per second to 10 meter per second upon hitting the bag, calculate the effective mass of the part of Pacquiao's body that moves forward to deliver the punch. So if we're going to illustrate the problem, so ito yung, for example, this is the mass of Pacquiao that is used to deliver a punch, and this is the bag. Okay, so it decelerates from a speed of 30 meter per second to a speed of 10 meter per second. And the time of contact, or the time interval, is 0.120 seconds. So we just have to put our given values here. The force is 3,585 Newton. The contact time, or delta T, is equal to 0.120 seconds. Uh, for the change in the velocity, so we just have to get v sub f. It decelerates from 10 meter per second to from a speed of 30 meter per second. So those are the given values. Now, when we talk about the force experienced by the bag, since in the third law of motion of Newton, in the third law of motion, for every action there is an equal and opposite reaction. So how much force is experienced by the bag if Pacquiao delivers a force of 3,585? According to the third law of motion, for every action there is an equal and opposite reaction. So if he delivers 3,585 Newton, then the return force from the bag will be the same magnitude but in the opposite direction. So if it is positive 3,585, then the force will be negative 3,585 newtons. Now, solving for the mass. So since that is what is asked in the problem. So from our equation based on impulse momentum theorem, F is equal to it's F delta T. So let's remove this. So we have your F times delta T is equal to mass times delta V. What is being asked in the problem is the mass. So we divide both sides by the change in the velocity. So we have force, or the mass, the effective mass, is equal to force times the change in time over the change in velocity. So solving that now, okay, so we have mass is equal to the force, which is negative 3,500, sorry, it's 500, 3,585, it's negative, times the time, which is 0.120 seconds, divided by the change in the velocity. It's from a velocity of 10 meter per second, 10 meter per second minus 30 meter per second. So the effective mass of Pacquiao, so if we're going to solve that, we have negative 3585 times 0.120 divided by 10 minus 30. That is 21.5 kilograms. So the effective mass of Pacquiao, 21.5 kilograms. So kailangan niyang i-forward yung bigat niya na 21.5 kilogram para i-deliver yung punch na yun. So the answer is 21.5 kilogram. Okay, so let's now proceed to the next, and this will be our last example. In a crash test, a car dummy of mass 75 kg moving at 15 meter per second collides with a stationary barrier. The airbag inflates and reduces the dummy's velocity to zero over a time interval of 0.5 seconds. Letter A. Calculate the average force exerted by the airbag on the dummy during the collision. Letter B. If the airbag was not present and the dummy stopped in 0.05 seconds, what would be the average force exerted on the dummy? Okay, so let's try to uh, solve the problem. Let's list the given values first. So first thing, we have the mass of the dummy, which is 75.0 kilogram. The initial velocity, which is the initial velocity of the car before colliding with the stationary barrier. So the initial velocity is equal to 15.0 meter per second. And then the final velocity, since during collision the car will come to a stop, sudden stop, the final velocity is equal to 0 meter per second. And the time of contact between the time interval, okay, it reduces the velocity of the dummy to 0 within a time interval of delta t, which is 0.5 seconds. That is with the airbag. Now, without the airbag, the time of contact is 0.05, which we'll be comparing later. So for the force, what we're going to find is the force. So from the impulse momentum theorem, force times the time interval is equal to the mass times the change in velocity. And then since we're trying to find the force, we just divide both sides by delta t. So we have the average force exerted is mass times the change in velocity over time. So solving that, we have force is equal to the mass of the dummy, which is 75, times the change in velocity, final velocity minus the initial velocity, so that is 0 minus 15, divided by the time interval, which is 0.5. Now, if we divide that, what is 75? So 75 times 0 minus 15 divided by time interval 0.5. That is negative 2,250. So negative 2,250 newtons. So the force experienced by the dummy is negative 2,250 newton. Now, what does the negative sign indicate? Ano nga ba ibig sabihin ng negative sign doon sa ating force? If we go back again to Newton's second law, the force exerted by the car is of course a positive because it's moving forward. That negative sign suggests that the force is in the opposite direction. Okay, so the force of the car is forward, therefore that force experienced by the dummy is in the opposite direction as the car. So that's the law of action reaction. Okay, it means that the force is in the opposite direction as the direction of the car. And how heavy or how large is 2,250 Newton? If we divide that by uh, 10. It means, sorry, 2 to 50 divided by 10. If we divide that by 10, there are almost 225 no, it's divided by 50. So, parang may 4.5 na 50 kilogram na tao na nakadagan sa'yo. So, ibig sabihin, 2,250 Newton force ay kasing bigat ng 5 tao. Now, let's compare if there is no airbag. Kung walang airbag, ang time of contact will be quicker, which will be 0.05 seconds. So, getting the force experienced by the dummy, so we have force is equal to the mass times the change in the velocity over the change in time. So that is, the mass is 75.0 times the velocity. Change in velocity is 0 minus 15 divided by the change in time, which is 0.05 seconds. So that will be, what will be the force experience? So we have 75 times 0 minus 15 divided by the change in time, 0.05. And that will be 22,000. It's negative 22,500 newtons. So the force experience, as you can see, it's 10 times larger. So, kung ang bigat ng 2,250 ay mga 5 tao lang, multiply that by 10, kapag walang airbag, yung force na 22,500 ay katumbas ng bigat ng 50 na tao na ang mass ay 50 kg. So, ganun kabigat. So, para kang dinaganan ng 50 na sako ng bigas. So, that is how important an airbag is during collisions. And not just the airbag, you must also use the seat belt. Okay. So that answers our question, why are airbags installed on cars? Why do foams not hurt when you punch them? Or why would you come to a stop by hitting a haystack instead of a brick wall with your car? So yung mga yan. Aside from that, sa mga athlete, they also catch a ball with this what they call a follow-through. So pag sinabi nating follow-through, ito yung, lalo na kapag mabigat yung bola, especially yung mga sports natin na may sinasalo silang bola at a very high speed. So instead of just keeping their hands na, for example, kung titingnan natin yung kamay ko, pag nandito na yung bola, pag sinalo nila, inaatras pa nila yung kamay nila. That is what we call a follow-through. That is to reduce the force experienced by their palm para hindi masyadong masakit yung pagland ng bola sa kamay nila. That is a follow-through. That is to increase the time interval to reduce the force experience by their hands. Another is when you jump from a very high place and then jump downward, hindi pwedeng naka-straight lang yung paa mo. Instead, you also bend your knees. That is because you are also increasing the time interval to reduce the force experienced by your knee. Kasi kapag hindi tayo magbe-bend, we might injure our knees. Another thing is on sa mga sasakyan, meron tayong tinatawag nating crumple zones. Or, di ba kapag nagbanggaan ang mga sasakyan, meron yung mga part na na-crumple yung sasakyan, and then merong part na hindi na-crumple. Usually, yung hindi naka-crumple na part is doon nakasakay yung mga tao. While the crumple zones are ito yung nasa harap at yung nasa likod. That is to distribute the force within a longer period of time. Okay? So, ganun yung ginagawa ng crumple zones sa mga sasakyan. Aside from that, ito rin yung dahilan. The concept of impulse is also the reason, or ito rin yung dahilan bakit hindi pwedeng ang mga helmet na ginagamit ay sobrang tibay. Dapat ang mga helmet ay babasag din. Hindi naman madaling mabasag, but hindi sila pwedeng very too sturdy. They should not be too sturdy. That is also to absorb the force during collisions. So that is the concept of impulse and momentum. And I hope you have learned new things about car safety and motion. Okay.